All right. Good afternoon, folks. Let's dive in. We're getting into part 2 of our exponent rules in our new unit, Exponents and Radicals. Let's check in real quick about practice problems versus homework problems. I've had a number of questions about that recently. When we say practice problems, when I say that, they're throughout the lesson, and they're problems I want you to do to practice what you're learning. I go behind you and provide the solutions. At the end of the lesson, I would provide homework problems, which are problems for you to do to practice what you're learning, and I'm often going behind to provide the solution to show you how to do them as well. So it turns out these are really synonymous. They're the same thing. So I'm going to try to quit even using the word homework and just talk in terms of practice. Practice is the problems you need to do during the lesson, the problems you need to do at the conclusion of the lesson, and what you need to turn in as your homework assignment. You're just practicing to learn. Okay? It's all the same thing. Don't get confused. Just do all the problems throughout the lesson and at the end. Turn those in. That's what I'm expecting. All right. First off, just a check-in from yesterday's lesson. The exponent rules we're learning are really simple. It's just a matter of, number one, getting them memorized, because there's 6 of them total. And then number 2, applying them in problems where there's multiple rules. And again, it's kind of fun. It's kind of like a logic puzzle. So I'm just going to practice these few for you real quick and then let you practice number 1, 2, 3. And you really just need a lot of reps on these, a lot of simple problems to kind of get these down. All right, let's start in. I see there's a multiplication going on. I'm going to start with these actual coefficient numbers in here, -5 times 3. I'm just going to knock that out. That's -15. Now I'll deal with all the p's. I've got a p squared and another p right there. Since they're multiplying and they're common bases, there's the invisible 1, and I know I add all of these exponents if I've got these multiplying common bases. So 2 and 1 is 3 total p's in the problem. R to the 3, R to the 4, same exact thing. Common bases that are multiplying, therefore I'm just combining those exponents. Remember, all that's saying is this. That's r cubed, and that's saying this. That's r to the 4th. So if I'm multiplying them all together, it's just a set of 7 r's being multiplied. In other words, I'm just adding the 3 and the 4, okay? That's kind of the review version of it. Let's do some more. -24 and 8 right here. That's just division. That's -3. Now I'll look at my m's. There's that invisible 1. 3 minus 1 means it's actually m squared. And n5 minus n4. Remember, if they're dividing common bases, that's just a subtraction. 5 minus 4 is 1. I could write n to the 1, but I'm just going to write n because the 1 is invisible as an exponent. Just get used to that, okay? All right, next one, we've got power to a power. That's the thing to notice. I can't work with this guy on the bottom and anything in the top yet because there's this sense of distributing with these parentheses. This guy's got to get connected to each piece in here. So that's actually going to be an 8 squared up top, and then an x to the 3rd times that 2. That makes an x to the 6th, because we're saying an x cubed, take 2 groups of the x cubed. So that's a total of 6. And now we've got the y squared. Now that we dealt with that power of a power on top, we can deal with that x squared on bottom. Let's deal with that. Don't leave any numbers like this, okay? When we start working on problems where you're going to have an actual real number and an exponent, go ahead and solve all of those out. You should write that as 64. We need to learn and remember and practice our exponents. That's 8 times 8. You need to have your times tables memorized and apply those on the exponents. And then we've got an x6 over an x2, so that's just a subtraction. 6 minus 2 with that common base dividing. So we've got an x to the 4. And then the y squared. There's nothing for the y squared to do that's left, so we're just going to keep it there, bring it to the answer. All right, there's those 3. You do your 3. Pause it, and I'll do them behind you in a sec. Go. All right, we're back. I'm going to do the short version to solve these. I talked through and explained before. Now I'm just going to give you solutions. Okay, there we go. All right, any questions? Somebody just talked to the video, I bet. Oops. I need to pay attention and not talk while I'm working. All right. Hopefully those are all tracking on how you got there. Let's move on. Okay, so that was review of yesterday's rules. There are a few more. There are 6 total, kind of 6.5. You learned 3 of them, plus that partial kind of half rule yesterday. So we've got the other 3, and we'll then cover that other partial rule today. All right, actually, no. I think you only have 2 more today. I think we've got 4 of the 6. All right. What does 6 over 6 equal? Or negative 3 over negative 3, or x over x. What do you think those equal? Think about it for a sec. Hopefully we go, well, duh, 6 over 6 equals 1. Anything over itself is 1. Negative 3 over negative 3. Anything over itself is 1. You could also think of it as pairs of negatives cancel. Either way, it's positive 1. We don't even need to know what it is. If it's an unknown, but it's the same thing, whatever x is, it's the same value top and bottom, we can also say that's 1, okay? So if that's the case, let's look at this down here. These are the exact same problems, but I left the exponent 1 invisible on the top set. I just wrote them on the bottom here. 6 is the same as 6 to the 1. So this bottom set is identical to the top, but what if I use my exponent rule? 6 to the 1 over 6 to the 1. Common bases mean I subtract those. 1 minus 1 is 0. It's kind of weird because that means I get 6 to the 0 power if I just look at the exponent part of it. Same exact idea. They're common bases with the negative 3's. I'm going to subtract their exponents. I end up with negative 3 to the 0. And even here with a variable, I end up with x to the 0 if I just subtract their exponents. Now, this is true. 6 over 6 does equal 1. Negative 3 over negative 3, x over x. Those are all true. But following the exponent rules we've learned so far, this is also true. Therefore, these must be equivalent. They must both be true. That means they equal each other. So that, interestingly enough, tells us 6 to the 0 must be equal to 1. Because we can see it's the same thing when we evaluate it both ways. Negative 3 to the 0 must equal 1. Interesting. X to the 0 must equal 1. We just determined the next exponent rule. Okay, here's another way we can look at it. 4 to the 3rd is 64. Remember that that's 4 times 4 times 4. Okay, and if I multiply that out, I get 64. 4 squared is 4 times 4, 16. 4 to the 1st power, that's just 4. So look at the pattern as we go down these exponent values. 64 tracking to 16, we're just dividing off one of those 4's. 16 down to 4, we're dividing by 4. So if we continue that pattern, 4 to the 0, what's it going to equal? We just discovered it's 1, which makes sense along with this pattern. 4 divided by 4 equals 1. So whatever makes sense to you, however you want to look at it, as you reduce your exponents down to 0, anything to the 0 becomes 1. Okay, so there it is right there. Anything to the 0 power equals 1. That's a variable, that's any number, that's a negative number. They all just become 1. So let's look at some rule practice here and see how this applies. If I have 5x to the 0, notice that the whole thing doesn't become 1 because that's only applying to the x. So that means 5x to the 0 is 5. Because x to the 0 is 1, we could leave it like that, 5 times 1, but that's just 5. So notice, guys, anytime something becomes 1 due to that 0 rule or any other way we use the exponent rules, if it's inside of a term connected to other stuff through multiply or divide, you can literally just cross it out, because 1 times 5 is just 5. So the problem's going to continue. Sorry, I got a bug flying around my head. The problem's going to continue without that x to the 0. It's just going to disappear, and what you're left with is 5. Side note, if we had 5x in parentheses to the 0, okay, now we're dealing with everything becoming 1 because it applies to everything inside the parentheses, which we see right here on the next example. All of this stuff in here is to the 0 power. So none of it matters. It all just goes away, becomes 1. Man, I love this rule. Makes life easy. So this piece here where we might have the y on top and the y squared to use our division of common bases, so we subtract, we're not going to do that because that y ends up disappearing anyway. It's just canceled out. It becomes 1. So all we're left with is the y squared on bottom, and it stays on bottom. That's it. All right, next one. I'm going to look at this problem and say, well, the 14 it's not raised to any exponent. It doesn't have anything that's going to be dividing on bottom with it, so that's just going to stay 14. Now I'm looking at my x's, and I see x to the 0. Well, that cancels. There is no you can look at it both ways. It cancels out to 1, so it goes away. Or if I want to apply the division rule, 3 minus 0 is still 3. Either way, I'm just going to stay with that x to the 3rd power. And now we look at the y's, same exact idea. That's just going to go away, leaving that y on the bottom. So he has to stay underneath. That's an important point, guys. Notice stuff on the bottom stays on the bottom unless there's a reason to move it to the top of the fraction. Something that starts the problem on the top of that fraction, that value, whatever it gets evaluated to, it all stays on the top. You can't just randomly flip things from bottom to top of the fraction. It stays where it's at unless you have a mathematical need to move it because the problem tells you to. All right, you try those 3, and I'll go behind you in a minute and do them. All right, let's dive in. Super easy. I see an x to the 0. Gone. Probably shouldn't use an x to cancel an x, huh? So all I'm left with is my -8, my y cubed. That's it. Next one. That 0 applies to everything, so all of this goes away. It just becomes 1. And 1 times the x cubed y is just x cubed y. So again, you can literally just cancel that out of the problem. It goes away. The rest of the term is all you're left with. All right, next here, focus on your values, the actual arithmetic, the math to do. 21 divided by -7, that's -3. Move on to your x's. I see a 0, so I'm going to cancel that, which means I still need a fraction. My x4 is still on bottom. And then I've got the y7 over 7. That's just the invisible 1. I'm subtracting the 7 minus 1, y to the 6. And notice it's on top. Because there were 7 y's, 1 subtracted away, he's still 6 y's up on top of the fraction there. All right, let's move. Random fact, you knew that was coming. Bullfrogs do not sleep. Now what I'm wondering about is Christmas Eve night. It must be horrible for bullfrogs on Christmas Eve. Because you know how long it takes to get through the night when you're trying to sleep. Imagine not sleeping all night long. It must take 3 years for a bullfrog to get to Christmas morning, it feels like. All right, next rule. We're going to look at this countdown that we used before. 3 to the 3rd, remember again, I'm going to keep hammering this because a lot of kids will mess this up when they're first relearning or learning their exponents. That's 27. It is not 9. This is what we're multiplying, and this is how many of them to multiply together. So it's 27, okay? 3 squared, that's 9. 3 to the 1st, that's 3. And again, notice what's happening. We're dividing off a 3 each time, because all the exponents are doing as we count upward is multiplying one more 3 into the mix. So we can see the pattern here. If we take 3 and divide off of 3, we're down to 1. Now, what happens if we continue this into the negatives? The pattern continues. We're still dividing by 3 because notice we went 3, 2, 1, 0, negative 1, negative 2. We're still counting down the number line. We just happen to go into the negatives. But this pattern of dividing by 3 each time, it's going to continue. So what's 1 divided by 3? Hopefully you said 1/3. And then what's that if you divide it by 3 again? 1/3 divided by 3 ends up as 1/9. So the question is, do you guys see the connection? 3 to the negative 1 is the same as 1/3. 3 to the negative 2 is the same as 1/9. Okay, and this shows our final rule, the negative exponent rule. And what do we see with this negative exponent rule? We see it right here. I'll write it out explicitly for you. 2 to the negative 3 ends up being 2 to the 3rd power, but on the bottom of a fraction, it's actually 1 over that value. So 2 to the negative 3, when we evaluate just 2 to the 3rd, if we pretended that wasn't there, that's 8. This also is 8, but it's on the bottom of a fraction. It becomes 1/8. And so what we see here is the negative exponent moves that term or that value to the bottom of a fraction. Under 1, okay, so it's a 1 numerator. So it just becomes 1 over whatever you've got. 2 to the negative 3 just becomes 1 over 2 to the 3rd. X to the negative 4th becomes 1 over x to the 4th. If I did y to the negative 6th, becomes 1 over y to the 6th. Whatever it is, the negative simply flips that term, that value, to the bottom of a fraction, and it's 1 over that value. Okay? Now, right here we said remember, and we showed why. This whole pattern is why that works. If that helps you get the understanding. 8, 4, 2, 1, 1/2. As we keep dividing by 2, 1 becomes 1/2, and we see right there, oh, well, 2 to the negative 1 is just 1 over 2 to the 1, which is just 1 over 2. Okay, and it'll continue to get smaller from that point out. Now, one thing, if you guys are thinking about it and you looked at the bottom of the page here, that's a good question. What about when it's already on the bottom and then you get a negative? What do you do there? We follow the same pattern. Think of it like negatives. When you have one negative, a number becomes negative. When you have two negatives, they cancel. So in a sense, the number flips back to positive. The same idea happens with a fraction. When you're already on the bottom and the negative tells you need to flip, that ends up putting you back on top. And if there's nothing else on the bottom of the fraction, then it's just over 1. And anything over 1 is just that value. So you still flip the value to the other side of a fraction. It just turns out that if it's on top, if you start with a whole number, you go to the bottom. If you start on the bottom of a fraction, it goes back to becoming a whole number. It just flips it to the other side. All right, let's apply it so you guys can see what I'm talking about. 8 to the negative 2, 1 over 8 squared. The negative moves it to the bottom. Now I can evaluate, which is 1/64. Another thing to notice, what do negative exponents do to numbers? 8 squared is 64. So normal exponents make numbers much bigger, much quicker. What do negative exponents do? they make numbers much, much, much smaller very quickly. Notice that 8 to the negative 2 is 1/64. So $8 versus 1/64 of a dollar, which would be like 2 cents. So notice that exponential numbers grow extremely quickly, and negative exponential numbers shrink into almost nothingness extremely quickly. Okay, that's what the nature of a negative exponent does. It doesn't make the number negative, it makes the number extremely small. Okay, all right, here we've got an x squared on top and an x3 on the bottom. Two ways to look at it. I think the easy way is first get rid of your negative, which says move him to the other side of the fraction bar, and now it's gone from the bottom. And then from here, I would just do the x2 and the x3 as those common bases, which is a total of 5. X to the 5, and you're done. Okay. You can also reverse that order, and it works fine. If you want, you can start with the bases and do the subtraction. 2 minus whatever's on bottom, which happens to be negative 3. But notice here, if you're not careful, you're going to get into trouble with your negatives. 2 minus a negative is a positive, which is still x to the 5th. If you want to look at it that way, I think that's a little trickier. So my advice to you, always deal with the negatives first by just rewriting something to the correct part of the equation it should be in, and then apply other rules to finish from there. Makes your life easy to get rid of negatives. Okay, next one. I'm going to do exactly what I just told you guys to do. I see an x to the negative 2. I'm just going to move it down here and make it x to the positive 2. That deals with the negative, and that whole x negative 2 is gone off the top. Now I've just got an 18 with nothing else going on. I've got an x to the second and x to the 4th on the bottom, so they're going to stay on the bottom, and they're just going to combine to make an x to the 6th. And then I'll deal with my y's. Y to the 3rd minus y is a y squared, and it stays on top because that's where it was to begin with. All right, last. 6 and 3, 18. Then I've got an x to the negative 2 times this x to the 4. So there is no fraction we can see, but there is. Everything is always over 1. Remember, any number can be turned into a fraction by making it over 1. So basically, we're just going to create the fraction that's not there at the moment. We're going to move him right to the bottom, and that becomes an x squared, and then it goes away. So now, all I've got left is this x to the 4 over x to the 2. And now I see it's a subtraction. 4 minus 2 is x squared, and you're done. And then I'm going to back up. Notice you can also do it another way. Some of you might have seen it that way. Totally fine. Whatever makes sense to you, use. I've got common bases multiplying, so you can go ahead and just go with your straightforward. Those are going to add together. Negative 2 plus 4 equals 2. And since it's a positive 2, it would stay on top. If we did this problem and ended up with more negatives, that would mean move your answer to the bottom to get rid of the negative. But we'll do more practice. All right, pause it, and you guys try that. Go ahead. All right, let's do this. 3 to the negative 4 just means 1 over. There you go. And don't leave it there. You need to finish evaluating any numbers you can. 3 to the 4th, 81. Okay, here we got y to the 5 over y to the negative 8. I'm going to get rid of that negative by putting him where he should go, which is now common bases, and that exponent's going to add y to the 13. Next, just take care of those values. I'm going to write it down below. I'm running out of room. 12 divided by 6 is 2. I'm going to get rid of that m to the negative 3 and just move it to the bottom. You know what? I'm going to back up, and I'm going to do something I should have been doing all along. Your guys' systems of equations quizzes were, for the most part, atrociously messy. And probably part of that is because I'm messy when I'm doing these problems, and I just realized that. So we are going to get neater. So 12 divided by 6 is 2, and I'm going to give myself space. I'm going to rewrite that problem. M to the negative 3, I'm going to move to the bottom, so now it's going to become an m positive 3 next to that m2. P to the negative 4, I'm going to move up. So that's going to become a p to the 4 on top, right next to the p to the 5. And now it's clear I can finish the problem. I've got 3 and 2 is 5 m's. Put them all together. P4 and P5 is P9. Keep those together on the top. And there we go. This is what things should start looking like. I'm going to expect that from you guys. I need to do better habits of being neat and clean. So do you. All right. Here we've got x to the negative 4. So that's going to move underneath. Now, I'm going to start requiring more out of you guys on the quizzes, or you're just not going to get points. You know what I'm doing here because I give you an arrow to show. You need to do the same thing. If stuff continues to magically move around and change in your problems, I'm not going to give you points, okay? So I can see what's going on because I'm showing you guys. You can see what's going on. And now I've got 2 minus 4 here, which is x to the negative 2. And now this brings up an extra piece you need to know and you need to do. Answers should never have negatives in them for your exponent. Simplifying, it's kind of like a fraction. When you talk about simplifying fractions, you always reduce them. When you're dealing with exponents, you always get rid of negatives before you finish. So if I end up with x to the negative 2, my final answer needs to bring that x down to the bottom so that there is no longer a negative, okay? Last rule, I think you probably already know this. I think we've already seen it, but I just want to make sure and point it out to you. If I've got negative 3p squared r to the 4th, so that's power to a power, that exponent 4, this guy right here, he applies to each part of that. And I think we've been doing problems to that effect, but I just want to make sure you guys are clear. That applies to each piece here. So that's the negative 3 raised to the 4th power. The p to the 2nd times the 4th is 8, because that's power to a power. And that r is also to the 4th power, okay? So those are equivalent. We just distributed out that 4 to each piece of the term. And then from here, you should finish. The negative 3 to the 4th would be, the negative is multiplied as part of those multiplying out. So if I was to expand that, it's like this. So since there's 4 exponents and 4 negatives, there's an even number of negatives, they all end up canceling. So that's going to be positive 81 as negative goes away. If they didn't want you to multiply all those negatives in, they would put parentheses and move the negative outside, okay? This would mean do the 4 first when you do the 4, and then apply the negative afterward. If you don't see that, you do what we just did here, okay? Always include your negative. And then there's nothing else to do. P8, R4, just copy it over. All right, same's true in fractions, exact same thing. So if you have a fractional power to a power, this guy goes to each thing inside. Every piece gets it. So I'm going to have an x to the 12 on top, y to the 4, and then on bottom, an x to the 4, and a y to the 4, and then just finish from there. Y to the 4 over y to the 4. That's going to cancel. Anything over itself cancels. It goes away. All you're left with is x's. And 12 minus 4 makes 8. Today there's a worksheet, guys, that accompanies this video. You can go ahead and work through that, and do not worry about calculating out all the actual numbers to an exponent, because they give you some really large ones, and I don't need you calculating up into the thousands. So if you get something like 1/3 to the 7th power, you can just leave it 1/3 to the 7th power. All right? Answers will be posted in class tomorrow.